Alright, here we are for hopefully the last of the blood study guide notes. We're ready to do the case studies at the back. Alright, so here we go. Starting with 32. We're talking about Mrs. Carlisle. She's in the hospital. This is Miss Carlisle. Whoops, that actually is not. This is Miss Carlisle. Alright, and this is her. And she is pregnant and has a little stick baby inside of her. Okay, not a greatest drawing, but you know, it could be worse. Okay, anyhow, so it turns out that her blood type is Rh negative, which means it just has a negative, A negative, B negative, some type of negative blood. Her husband over here is Rh positive, okay, and because that's dominant, the baby is going to be Rh positive, okay, and so a lot of times this is not a problem, okay, because the mom's and the baby's blood does not ever mix. However, sometimes, say the blood vessels in the placenta tear or something, and the blood actually mixes between these two. Well, the baby's blood negative, which means it does not have the Rh factor. Rh, just for the record, stands for rhesus monkey. That was first discovered in rhesus monkeys, and then they found similar things to people. And so anyhow, so Rh negative. Negative means it does not have it. When the blood mixes with it from the mom, when the baby's blood mixes with the mother's blood begins to make antibodies. Okay, we'll say anti-Rh positives, and they go and start attacking that. Okay, now, even though the blood from the mom does not cross over into the baby, these antibodies can, and if they do, they start attacking the Rh positive markers on the baby's blood and can start destroying it. Okay, this is called the hemolytic disease of the newborn. Okay. Although in this case, if somehow the blood mixes, it tears or something, then it can't happen while the baby's still in there. Now, hemo means blood, lytic means to destroy or attack and split and burst. And so basically the mom's antibodies are attacking the baby's blood and causing it to burst. Okay? Like I said, usually it's not a problem because usually the blood does not mix until the baby is delivered. And as the placenta tears and stuff, as the baby's delivered, the blood mixes. Then the mom makes antibodies, and it's going to be a problem the next time she has a baby, because as soon as that baby with Rh positive blood, the antibodies will get in there and start attacking its blood. Okay, but generally speaking, it's not a problem the first time unless somehow it tears or something and the blood mixes. All right, now the question is number 33. Why is the baby's cyanotic? Cyanotic means blue. Okay. Not as can be confused with sayonara, which means bye-bye. But because basically so many of the red blood cells have been attacked, okay, that doesn't have enough to get enough oxygen. Okay, they've been attacked by the mom's antibodies that they cannot get. There's not enough oxygen, and so basically that's why it turns blue, because it has a shortage of oxygen. Okay, and the third question, 34, is because it's her first pregnancy, how can this have happened? And basically that's where at some point there must have been some tear in the placenta, and fetal red blood cells must have crossed over into the mom's blood and mixed somehow, and so the mom began to make these antibodies, and then the antibodies can pass over the placenta, even though the actual blood does not. All right, now number 35 says, assume that baby Carlisle was born pink and healthy. Say it had not torn, they had not mixed the blood, the mom did not make antibodies, it was born fine, but during the delivery, the mom would have, her blood and the baby's blood would have mixed, and the mother would start making antibodies. Not a problem for this baby because it's born, it's out of there. But the next baby, as soon as, if it has Rh positive blood, then the mom's antibodies are already there, already built up, has a full set of them ready to go, and they're going to start attacking it. So what happens is, if for the next baby, they would give her a RhoGAM shot, okay, or injection, and basically it's an immune serum, okay, that prevents the mom from being sensitive to the Rh positive and keeps her from making antibodies. Okay, and so basically if they give this shot to the mom beforehand, then she will not make it. Eventually the shot will wear off, but by the time it's worn off, hopefully by then the baby has been born, and so it is safe. Okay, so anyhow, that's kind of basically the setup there. And the next question that asks what would happen to Miss Carlisle's sisters had 2 miscarriages before seeking medical help. And these miscarriages were probably caused by the mom's antibodies attacking the newborn and eventually killing it. It got so low on oxygen that it couldn't survive. So basically they would do the same thing with her as we talked about on number 35 for Mrs. Carlisle. They would give her the RhoGAM shots that would prevent her from making the antibodies that would attack it. All right, now we're going to talk about blood types for a second. All right, now there's a blood type worksheet, and you will be doing that, but let's just go over some of that real briefly here. Basically, let's look here. These are your red blood cells. All right, if a red blood cells can have little markers on them, represented here by the yellow dots or the little spiny things, all right, or none at all. Okay, if there are no markers on the outside of the blood cells, these are called O because there are no markers on it. Okay, and so O means it doesn't have anything on the outside edge to be recognized or attacked. If it has little sharp ones, in this case, or they're using those little pointy ones, they're representing that as A. And if it has A antigens, notice these are antigens, all right, then it would be type A blood. All right, up here at the top, if it has little yellow ones, I'm not sure if y'all can see that. Let me bring it down a little bit. Switch these out a little bit. Okay, so you can see them. All right, if it has little yellow ones, those are type B antigens. Okay, so those are B antigens. Okay, and that would be type B blood over here. Okay, and if it has both the B and the A, then it would be type A B. So they're named for the type of antigens they have. Okay, and so AB blood has A and B antigens. O has no antigens. A blood has A antigens, and B blood has B antigens. Now, here's the deal. If you give someone blood that has some kind of antigen that they do not have, they're going to attack it because they say, that's not me. Okay? If you're an O-type blood, you have no antigens, so either A or B ones will cause that to get set off. Okay, and so they will attack anybody's. So the only blood they can receive is other O blood that has no antigens, otherwise they attack it. On the other extreme, you have AB, where they already have A and B, so any kind of blood you give them will not have any antigens that they don't already have. And so they can receive blood from anyone. And so the question, first of all, which one is universal recipient? All right, the universal recipient is type AB because they already have A and B antigens. They can take blood from anyone. If you give them O blood with no antigens, well, there's no antigens they don't already have, so they're not going to attack it. If you give them B blood, well, they already have B antigens on their blood, so they're not going to attack it. If you give them A blood, they already have A antigens, so they're not going to attack that. They can get blood from anybody. Okay, now O is the universal donor. Okay. And so they can give their blood to anyone because they don't have any antigens. Because if you give to A blood, there's no antigens, so they say, I can take it. So you can give O blood to anyone. And so blood banks are always calling up people who have O blood and say, hey, would you like to come give us some blood? Because they know that they can use their blood always. All right. So O is the universal donor. AB is the universal recipient. Okay. To be specific, O negative. There's also another factor on here we talked about with the last one, which is RH factor, positive or negative. So to be best, O negative doesn't have the RH factor, then it has none at all on it. It can be given to anybody. And AB positive would be the universal recipient because they could get it from anybody. All right, we'll talk more about that on the blood type worksheet, but for now we'll let it go at that. Okay, number 38 is talking about a transfusion, okay, or a transfusion reaction, and it wants to know what happens on this. Okay, well, let's talk about that real quick. All right, so a couple things. One, if you give someone the wrong blood type, okay, hopefully this is double checked, and they even have barcodes and everything on them now and stuff in the hospital to hopefully not do that. But the first thing is the antibodies attack or attach to the RBCs, red blood cells, okay, with unknown antigen, something it doesn't have before. So if you give B blood to someone with this A blood, they don't recognize the B and they start attacking them, okay, because we don't have that antigen. All right, so that's the first thing. Now, because of that, you get what we call agglutination or clumping. Just a fancy word, but you need to know it. Agglutination, think gluing together, clumping of red blood cells. All right, so that's the next thing that happens. Now, because of that, as it attacks these, the red blood cells are lysed, which once again, lytic, means to burst or whatever. So they're doing it, and this releases hemoglobin. All right, because remember, they are just little packets. Red blood cells are just little packets of hemoglobin. So now, because of all these red blood cells being destroyed, there are low oxygen levels in the blood. But that's not really the big problem here. Actually, what happens is the hemoglobin molecules clog up the tubules in the kidneys, and you actually die of kidney failure. So that's what's kind of odd. You actually die of kidney failure, but it is related back to the transfusion problem. Okay. All right. Number 39. Mrs. Pratt claims that Mr. X is her father. Miss Pratt is type O blood, and her baby boy is A positive. Okay, and she's O negative. All right. Mr. X's blood is typed is found to be B positive. Okay. Could he be the father of their child? Now we'll talk more about this later, but if you have O blood, you're OO. That's your two letters or your two alleles for the trait. B is either BB or it could be BO, but either way, there's no way this father could have given an A to make the baby. So the correct answer is no, this is not the father. Okay, the father has to be an A, and since the mother's negative, it would also have to be A positive. So the dad would have to be A positive, and that would be the expected blood type for him. And so Mr. X in this case is not the father of the child. All right, real quickly, on the last paragraph says fetus has a special type of hemoglobin. It's called fetal hemoglobin, or the fancy word is HbF, the F for fetal. All right, and it has a particular affinity for oxygen because if you remember, the blood coming through the placenta of the mom is not necessarily coming straight from the lungs. It may have given off some of its blood along. So the infant's blood really grabs up oxygen very good, so it needs a special hemoglobin. Now, when the baby is born, it doesn't need that, and so it has to destroy and get rid of that hemoglobin. It's replaced by what we call hemoglobin A. Okay, regular hemoglobin, and so it's having to get rid of that old hemoglobin, and sometimes the new liver is not up to that, and so it ends up with the baby being very jaundiced or yellow because it's not getting rid of those byproducts, the bile and stuff, bilirubin and things that come from the red blood cells, and it causes it to be jaundiced. All right, the next one is genetic factors when you have anemia that under low oxygen conditions is sickle cell anemia. All right, we kind of already talked about that a little bit. All right, Bleeder's disease is hemophilia. All right, and the next one would be iron deficiency. When they don't have enough. Also, because women bleed monthly during the menstrual cycle, they lose blood there, and so that causes that to be a problem for them. The next blank is pernicious anemia because if the gastric mucosa is not working, they can't absorb, and they need vitamin B absorption. So that's the next blank. And the next one is either embolus or